All right, hello everyone. Today we're solving Leet code 104, find maximum depth of a binary tree. The maximum depth of a binary tree is defined as the nodes along the longest path from the root node to the farthest leaf node. And leaf nodes are just the end of the tree, and the root is the first node in the tree. So the longest path between the root and the leaf node would be 1, 2, 3 to the 7, or 1, 20, 15 to the 15 here, and that would be a 3-node traversal. Either way you go, so the maximum depth would be 3. Here I've recreated the same tree, but I had an extra node, and I want to show you how to find the maximum depth of this tree using a stack and an iterative approach. So the first thing I'd like to do is define a variable called max. This is just going to hold our maximum depth that we found throughout the tree. And it's going to start off at 0. And we're going to initialize our stack with the root node, which in this case is 3, and the depth. And the depth is 1 because let's say none of this existed and we just had the 3 node here, the depth would be 1 node. So we know that. And next, what we're going to do is in our while loop, we're going to say, is the depth of our current node greater than our max? Our max starts off at 0, and the node that we're looking at has a depth of 1. So our max is now 1. And since we've popped off this node, this is no longer on our stack. And now we want to say, does the node we're looking at have a left and right child? It does have a left and right child, so we're going to add that first, which would be a 9. And as for the depth property, we would just add 1 to whatever the parent node's depth was. The parent of 9 is 3, and it had a depth of 1, so now 9 will have a depth of 2. And same thing for the right side. We add the 20, and the parent node is 3 with a depth of 1, so we're going to make that plus 1, which would be 2. Perfect. So now these nodes have a depth of 2, and we're going to pop off the top of our stack. So now we've popped off the 20, and we're working with that now. We're going to say, is the depth of the node we're currently looking at greater than our max? It is. 2 is greater than 1, so this will be a 2 here. Make sure to get that in the right color. This would be a 2 here. And we're going to say, does it have a left and right node? It does. So here we have 15. And we're just going to do 1 plus the parent node. Parent node of 15 is 20 with a depth of 2. So now we're going to give that a 3. So we know this is 3. Same with the right node. 7. Its parent is a 20 with depth of 2. So 1 plus 2 is 3. And we've done that. Beautiful. Now we're going to go to the top of our stack, which is the 7. Same story here. The depth is greater than our max, so we update that to be 3. We say, does it have a left and right child? It does. So we're going to add that to our stack as a 26 node, and a depth would just be 1 plus the current node we're looking at. So this would be a 4. And we already popped the 7, so we're done with that node. And now we just look at the top of the stack again, which in this case would be the 26. So we pop that off, and we're going to say, since this has a depth of 4 and our max is 3, we're going to change this to be 4. Now our max depth is currently 4. And this doesn't have any children, so we're not going to add anything to our stack. Now we go to the next available thing on our stack, which is the 15. So we pop that off. And we say, is the depth of this node greater than our max? It's not, so we do not change it. We leave it at a 4. And we're not going to add anything to the 15 or to our stack because it has no children. Both of node 15's children are null, so we're not going to add anything there. Next, we're going to go to the 9. Same story here. 2 is not greater than 4, and it doesn't have any children to add, so our max depth we return is 4. And we're going to get into coding up the solution. So first we want to say, let's say we're given an empty node. So if the root is null, we just want to return 0 because there's no nodes to actually traverse. It's an empty tree. Next, let's actually get into the meat and potatoes of the solution. So now we're going to initialize our stack. So let stack equal the root node and its current depth, which we know would be 1. And we're going to initialize our max variable. So let max equal 0. Now we're going to say while stack dot length. We're going to store our There are two values that we have in our stack onto two variables. So we're going to say let node comma depth equals stack dot pop. So this would just store the node we're looking at, which in that case here would be the 3, and the depth would be 1. And here we're going to say max equals math dot max between the current depth and the current max. There we go. And now when we want to push things into our stack, we don't want to push any null nodes. So we're going to say if node.left is valid, i.e. not null, we want to stack.push node.left, and for the depth, we're just going to go depth plus 1. And same thing for the right. So now we're going to check if the right is null, and if it's truthy, we want to push it onto the stack. Push that onto our stack, and we're going to do depth plus 1. Same thing here, looks pretty good. And at the end of this, we want to return max. And let's see, did we get the right answer? There we go. And we actually were able to pass the solution, and it was pretty efficient. Question iteratively, I'm going to show you guys just a little treat how to solve it recursively, which actually is a lot simpler. What we're going to do is add 1 to every recursive call, and our base case will be when we hit a null node, just return 0. So let's say we're going down this tree, we're going to go DFS. We're going to go to the left first, and we're going to see that this is a node 1. So we're going to return 1. And the first call already returned 1, so we're going to have 2. This would return 0 because of the null node, and we go back up. So now the left-hand side has a max of 2. We're going to DFS on the right-hand side. This would be a 2. We go down here, 3, 3, and then 4. The right-hand side has a maximum depth of 4, and we just grab the math.max between both of those. So basically DFS, but add 1 to each return to call. I'm going to show you this really quickly. If the root equals null, just return 0. And here we're going to say return math.max of max depth of root.left, comma, max depth of root.right. And we're just going to add 1 to each call. And this should give us the answer. Let's try it out. And there we go. That's how you solve it recursively. And it's a lot simpler. All right, I hope you guys enjoyed the video. Peace. Drop a like, do all that good stuff.